Okay.
I just wanted to introduce you first. Jarkko, you are so eager to talk. Welcome again, everyone, to the Flower Stage in ETH Prague in Saturday. The next talk will be from Jarkko Sakkinen. He will be talking about logging to Linux using Ethereum Name Service. So a big round of applause for Jarkko.
Okay, thank you. So, okay, I'm Jarkko Sakkinen, and okay, those are visible there. Okay, perfect. I'm a software developer, Linux kernel hacker, and also Linux kernel maintainer. I maintain like mostly like crypto stuff. Like I'm a co-maintainer for Linux keyring. I'm co-maintainer for TPM2 and Intel SGX and that sort of stuff. So when it comes to Ethereum, I'm not really interested on Ethereum per se, but I'm more interested because I'm the person. If you, for example, set a new key type to kernel, I'm the person with the veto right for that key type because I review all that stuff. So when it comes to Ethereum, my main interest is to find something in that ecosystem that will also be like for the benefit for other ecosystems that use, for example, similar basic like crypto keys. In the case of Ethereum, it would be the P256K1 curve that also Bitcoin uses and some other blockchains. I don't know if the Estonian government uses those also for their IDs, but it could be possible. I don't know. But anyway, it's very common. So from that perspective, it would make sense to enable that curve, for example, in the kernel and some other like even in some like standard hardware chips and stuff like that. So my original idea was to develop a PAM module for Linux, which is basically like a shared library module. You can put it in the config file, and it will give based on credentials like a yes/no answer to you. And you can pile them up, and all the like session managers like GT and GNOME, GDM in GNOME and others use those to make like the decision whether you get in or out. And Ethereum ecosystem has like some tools for it, like for instance this Ethereum Name Service that can be used like basically like corporates use LDAP. You know, store key value storage where you can store data per person and use that for authentication. And then there's this exchange kind of key exchange or authentication scheme called Sive. And that in particular would be, like, in my opinion, suitable for OpenSSH, which already has this feature that you can have multiple different ways to exchange. The problem with implementing that for OpenSSH comes down to that ENS does not provide any C libraries, which would be like, I think with all these technologies, it's a huge minus that almost none of them have any like basic C libraries. It's super important if you want to get like to data centers and like to the internet backbone to still today to have C libraries, because then when you have the C libraries, like the legacy but still widely used like DNS daemons and software like that could just take those C libraries and add in, you know, the Ethereum shenanigans in the existing like software tag, which is not today possible because basically all of it is implemented with web technology. So I would highly promote to also do like standard like basic C libraries. There, I did some experiments with libcurl, libsodium, and there was one third library. I don't remember what it was, but anyway, mostly with libcurl and libsolun, all right, and libglib JSON, and I could do like basic quite within like hour. I could do like basic like lookups from it, the ENS and basic transactions and stuff like that. So it wouldn't be like that huge of an effort. And if you had that C library, then you could easily move into extending like OpenSSH to support Sive, for example. But the main problem for me came out by identifying the two roles. Well, these exist like in any remote attestation or authentication scheme. So you have basically like two roles. You have the user who is logging in, and then you have the machine, which also should have an identity. And here the problem is that both parties need a private key, but neither of those private keys should be exposed. So I kind of gave up implementing anything the PAM module because I thought that this is much more like important problem to solve. So how to store the identities? Well, there's this whole market of these crypto wallets, and they probably work for you if you are like particularly interested in Ethereum. But they don't work for me because I haven't eaten yet the red pill. So yeah, and I do have a YubiKey, but I use that for like for my when I access for kernel org, I use YubiKey for SSH authentication. But I use it because I have to use it. So something is needed that could bring like almost like equivalent characteristics as crypto wallet, but with a lower barrier. So I think TPMs, especially the new TPM2 standard or semi-new, it's 10 years old, but like as an industry standard, still quite new. Every PC has one of these, and all of them did today support TPM2. Its primary keys, it doesn't store any primary key. It actually stores like a few random seeds. So that way, the trusted computing group can add new algorithms to the standard without changing the hardware. Hardware only needs like basically a firmware update. So if they want to add a new elliptic curve type, they first make the decision in this cross-corporate industry group called TCG that okay, we want to add this. Then they update this single specification. Hold on, I can open it here, and I'll find it out. Okay, so and they have, for example, for elliptic curves, they have this table that these are like at the moment TPM chips support this set of elliptic curves. So the one curve is obvious curve is missing. There's the NIST curve here NIST P256 R1, and but the blockchain semi-standard curve P256 K1 is non-existent. So and also already today TPM2 chips can do like ECDSA, but only with these elliptic curves. So ECDSA is supported. They support elliptic curves, so they have all the like the computational like tools to also support like this curve that Bitcoin and Ethereum use. So it's mainly just get that thing to decide it TCG level, and I talked with one like pretty senior member of that group from and it was not like that. At least from that person, that he said that it was not like that he would be against like adding this curve because blockchains or whatever. It was only that he did not know that anyone uses P256K1, because if you do your crypto stuff here and are not involved in blockchain there, then you might sometimes some curve lacking from some standard. It might be just because of pure ignorance, not because the evil corporation don't want to add it or an NSA wants to prevent adding it or whatever. I heard this internet rumor that the curve does not exist in this table because NSA does not want it to be there, but I don't believe so, because that was based on that because K1 is based on prime numbers. That for some reason NSA would only want to have composite number, but that cannot hold because also 25519 curve is based on prime numbers, and at this it's claimed to be more secure than P256K1, so that kind of disapproves that internet rumor. So where? Oh, okay, trusted computing. It's trusted computing. Anyway, so I think a good goal for Ethereum to make it spread more easily and get the same benefits as with crypto wallets, like to every PC and even like a lot of Android devices, like a huge spread would be to get an ID to that PDF file. That would like enable like most of the laptops in the world to have a hardware crypto wallet. So it would have like huge volume, and yeah, it would bring equal of benefit for both Bitcoin and Ethereum and all sorts of blockchains that are based on these. So one thing that I maintain in the Linux kernel is Linux kernel keyring. It's a runtime keyring, and it's used like when you log into GNOME or whatever to store some sessions keys and stuff like that. And it also has so you can have you can define various keyrings in it and key hierarchies, and it also has an asymmetric key type that can import like X509 ASN1 encoded, pretty standard stuff. And the currently, for no particular reason, even in software, it only does ECDSA verification, and only for the NIST curves. I'm planning to at some point implement also signing for ECDSA just in software, and at least in software at also support for this blockchain curve type. But the first thing that I started working on was this kernel patch set that can sign stuff with the private key in the TPM, both using RSA, letters are in the wrong order, PKCS1 patch scheme, because that you need to patch what you sign in RSA to get it actually secure, and also I implemented ECDSA for the NIST curves, because those are in the table. And here I don't, so it's going quite well. So it's relatively simple now to create. So this is normally you would have this primary key here already like in. So you usually when you use TPM2, you don't usually use this non-volatile memory. You only use the non-volatile memory in TPM for like to have some primary keys or like root keys for the TPM itself for like creating other keys. So this is just for the demo. I create like a simple primary key here, and then I export it out of the TPM. And then I create like a NIST elliptic curve key with OpenSSL and what does this do? Okay. Then I import that. Then I convert that back to do various steps. I don't remember exactly all the details from this. But anyway, through these steps, I create the key and finally export ASN1 that is like only loadable by the TPM chip itself. So it exists in the hard drive, but it's sealed with the TPM. Only the TPM can unseal it when it does an operation. So basic keys when using TPM for signing operations is that you don't keep the key always in the TPM. They have very low memory, but instead when you sign, you load the key inside the TPM. It will open it up inside the TPM. Then you do the sign operation, and then you flush the loaded key out of the TPM. And okay, so for NIST curves, I have now like. So hold on. Okay, so to make this less confusing, these operations here are only like for doing necessary conversions and encryption for a key that was originally created by OpenSSL and not the TPM by itself. So this whole framework support importing the existing private keys for the as TPM keys. Okay, so anyway, with this NIST curve-based keys, I can now do like perfectly signing and verification operation, which is like the whole gist of what it needs also for blockchains. So, and basically all this code that I've done for this would only need like few line modifications to be able to sign also like P526K1 curve. So I'm planning to get this feature upstream for Linux 6.11. So at that point, at least the software stack almost supports ECDS. There's my ECDS encoding code. So, but anyway, so after this is in, if TCG added that one algorithm ID to their table, then Linux could support within few months also like signing these blockchains. So, and I whether that's worth it or not, I would think it from this perspective. Would the world be a better place if TPMs could sign blockchains or not? I think I mean crypto wallets might make sense for some, but I think this could be like more like, more inviting way to do it, because then you could easily, for example, have even for Windows a crypto wallet app that would like automatically, just like with BitLocker, it would just automatically use the hardware sealing. Yeah. So in this example, hold on. Okay. Yeah, I'm almost done. So in this example, as you can see, there. Okay, no, that's RSA example. Okay, there, it's Nisker, but if I change it that whole transcript by creating like 6P256K1, which is the one that Ethereum uses, at the moment it is not accepted by the TPM. So this constant. This is what would make a lot of sense for all blockchain technologies, and I think it's possible to do. So okay, okay, TCG membership is quite costly, so it at most would make sense for like Ethereum Foundation or Bitcoin Foundation as a whole org, but Ethereum has like membership companies like Microsoft who invest a lot to Ethereum. So if I was active in Ethereum, I would contact these companies who have investment in Ethereum and talk to them about this issue, and then they could within TGC meetings bring this up. So I think that might be possibly the best road to get this in. But yeah, so questions?
Thank you very much, Jarkko. We have 4 minutes for questions. If we have questions from the audience, feel free to ask. Don't be afraid. Yes, one question here. A mic is coming.
Yeah, do you have any idea about like the details of the process for getting stuff through the TCG and like how long it takes normally?
I don't know, but for example, with Intel, it's just like that when they otherwise do like a BIOS update, then that will also like include like the update for their firmware TPM. So but I would say that within like at least 6-month timeline, it is quite probable that it would end up. So not that huge timeline.
Thank you.
Any other questions? One more over here.
Thanks a lot for the work. 2 years ago, I was talking to a guy who was like planning on building lightweight Ethereum wallet, thanks to like with YubiKeys actually, or some other. So I think it's very related to what you are like talking here about. So I would love to get you in touch.
Okay. Yeah.
And but the question is, so are you personally looking for a grant on like working on this as well?
Yeah. So in the sense that I spent last nine days implementing the basic feature for kernel, like TPM2 asymmetric keys, and it can already do easy DSA with the NIST curves. So and it would be quite easy to add later on some new curve types.
Amazing work. Thanks.
Yeah. Thanks.
More questions? We have 2 more minutes, if there are any. The last, yeah, there we go.
Do you intend on doing anything more on this? And if so, what? Or like what
yeah,
what's the next step?
So since TCG does not yet support this curve type, and so after this patch goes to the mainline, I was thinking to just like, so that at least like some for some prototyping, it would make sense to have the ECDSA for this curve type supported by the kernel in software. So, you know. So I was thinking to implement that next, just software keys for ECDSA signing.
Where do you need help?
I don't know.
If there's anyone in the room who's interested in supporting this.
Well, I think like I don't have time and energy to fight with TCG. so you know, there must be like for example Microsoft is investing to both TPM2 as a technology and also to Ethereum in the data center. So I would, if I was like active in Ethereum, I would talk to Microsoft maybe.
Cool.
Because I think for Microsoft it would make a lot of sense to have this in, especially if they use it in the data centers, you know.
Cool. Thank you everyone for your questions. If you have other questions, you can catch Jarkko. We have to continue with the schedule, but big round of applause for Jarkko for this thought-provoking talk. And our stage will continue in 4 minutes at 11:30 with the schedule. See you in 4 minutes.